Okay, everyone. Good morning. And today we're going to discuss about projectile motion exercises that I given before. So let's look at the exercises. Okay. So first of all, what is meant by projectile motion? So projectile motion. Okay. So I put this A projectile motion. Okay, is the motion of an object. Okay, horizontally and vertically simultaneously under the influence of gravity. Okay, so that will be the definition of projectile motion. And B, a ball is thrown downwards at 30 degrees below the horizontal from the stage of height 2 meter. It reached the floor after 0.2 seconds. First, determine the initial speed of the ball. So, as usual, we have to sketch what is happening in the diagram. So, we have a height, okay, and then we have a ball is thrown downwards. So, it was not initially was rolling, but it was thrown. Yeah, that is 30 degrees to the horizontal. So, this is 30 degrees to the horizontal. What happened then it will be having a projection towards the floor, going to the floor, and after that it will happen by 0.2 second from the top to the bottom. Okay, so it says that the height is 2 meter, so this height over here is 2 meter to the floor. Okay, to this floor, and we're going to determine the initial speed of the ball. Okay, so we have to find what is the initial speed of the ball. We're using the vertical motion. So vertical motion is up down or y axis or vertical motion. Okay, so what we have is we can use s equals to ut plus 1 over 2 at squared. So in the y axis, okay, we have 2 meter. We have also determined what is the u over here, because only is a u in y direction. So s is 2 meter equals to u sine 30 degrees, okay, times 0.2 and plus 1 over 2, 9.81 and 0.2 meter squared, or 0.2 squared. You can see that over here the g is positive because we already we can make a understanding that is pointing down is positive. Okay, that's why the g over here is positive. Okay, and one more v over here also is pointing downwards, so that's why we are using positive. It's easier to use rather than pointing up is positive. Okay, so we have two u sine 30 plus times 30 0.2 plus 1 over 2 9.81 plus 0.2 squared. So u, okay, will be 18.04 meter per second. Okay, so this is the initial speed of the ball, 18.04 meter per second. Next, calculate the distance of the ball from the stage. Okay, so distance for the ball from the stage, we use a horizontal motion. So horizontal motion. So this is the ball. Okay, it's on top of the building or what. And then we have here what is the horizontal motion, I mean the range between the initial to the final of the ball. So what is the length over here? So by horizontal motion we have x equals to u cos 30 degrees times t. Okay, because you know that in the horizontal motion there are no acceleration, so you have x is equals to ut, so equals to 18.04 cos 30 degrees and times with 0.2, so you have 3.61 meter in the horizontal. So it means that this point from end to end is 3.61 meter. Okay, and number 3, we're going to the next question. For question number B3, we use the vertical motion. Okay, I mean in the y direction, y-axis direction. Vy equals to uy plus gt. Okay, and where we have equals to 18.04 sine 30 degrees plus 9.81 times 0.2. Okay, so we have 10.98 meter per second. And for getting v, I mean the velocity of the ball, this is in vy, we want to find v. Okay, so square root theorem Pythagoras, 10.98 squared plus with 18.04 cos 30 degrees. Okay, and we have v equals to 19.1 meter per second. How about the angle of projection? So tangent theta equals to vy over vx equals to 10.98 divided by 18.04 cos 30 degrees. Then the angle will be equals to 35.1 degrees below horizontal. Okay, so it will look like this. This is horizontal, then will be 35 degrees angle with 19.1 meter per second. Okay, it is a vector. Next we have question number 4. If the ball is projected horizontally from the stage with the same speed, compare the speed of the ball to reach the floor with B3. So it says that if the ball only roll, it doesn't shoot, I mean the throw directly downwards, it was roll. So we have only u in x direction, and we don't have u in y direction, so we don't have this number. Okay, so what happened is I'm going to draw again. So this is the ball going in the ux only. Okay, so it will be going in 18.04 meter per second, because u in x we have calculated before is 18.04 meter per second. Okay, so and then we want to find the speed, right? We want to compare the speed. So what will be the v here? Okay, but by getting this v, you will have to find what is the vx and how much is a vy. So vx is the same, 18.04. Okay, as you remember, in the horizontal motion there are no acceleration, but how much is vy? So to get vy, vy squared equals to uy squared plus 2gs. Okay, 0 plus 2 times 9.81 times 2 and equals to 39.24 meter per second. So it means that this vy is 39.24 meter per second. Okay, now we're going to find how much is the v. So we have to use a factorial integrals. V equal to square root of 39.24 plus with 18.04 squared. Okay, so this is already squared actually. Okay, and V will be equals to 19.1 meter per second. Okay, so we also has the answer 19.01. If you remember in the question number 3, this is question number 4. In the question number 3, we also have 19.1 meter per second as the vector. So it says that it is equal. Okay, if the ball roll or the ball thrown below the horizontal by 30 degrees, it will be same. The speed will be same. Okay, going to the next question. Okay, for question number 2, a hot air balloon rises and with a velocity of 50 meter per second. Then it is 12 meter. When it is 12 meter above the ground, the sandbag of mass 0.5 kilogram is released. The diagram below shows the path taken by the sandbag when it was released. So A, write equation to show the direction, show the horizontal motion and vertical motion of the sandbag at the time t. Hence, derive an equation represent the trajectory of a sandbag. So let's discuss what is happening in the question. First, there was a hot air balloon. Okay, let's say this is hot balloon, and then it goes up, and then when it reached 12 meter above the ground, okay, the sandbag was released was thrown out from the hot air balloon, and it makes a projectile motion towards the ground. Okay, so it's assumed that in this sketch it was thrown by 50 meter per second from the hot air balloon and reaches a certain height that is 14.2 meter, and then it fell down to the ground of the floor. Okay, to the ground. Okay, so right equation, as we know that we have two equation, that is either is horizontal equation, or we have vertical equation. Okay, so we have two, but if we need to combine both of them, we can, but we have to pitch out with the time. So vertical motion, vertical equation put in the time, and this time put again in the horizontal, substitute in the horizontal equation. Then we have the whole equation in the equation itself, in the formula. So first of all, we have to start with the horizontal motion. So horizontal motion, okay, it's better use, okay, horizontal motion, x equals to 15 cos theta t. Okay, ut, s equals to ut. And for vertical motion, okay, y equals to 15 sine theta t minus 1 over 2 gt squared. Okay, this is for vertical motion. So t, okay, equals to x divided by 15 cos theta. This one came from the top. Okay, from this part we substitute into this part, that is t equals to x over 15 cos theta. And so y equals to 15 sine theta, and x divided by 15 cos theta minus 1 over 2 g x divided by 15 cos theta and squared. Okay, so what we have here is equals to x tangent sine. Why got this tangent is because we have sine divided by cos, we have tangent theta, okay, and minus with gx squared divided by 450 cos squared theta. So there will be the whole equation y equals to x tangent theta gx squared over 450 cos theta for the whole equation of the question. Okay. Next, find the speed of the bag at the point P. So what will be the bag at the point P? So we can use actually this is conservation of energy. Okay. So how much the total energy? Total energy at P is equals to total energy at O. Okay, so half mv squared v1 plus with potential kinetic energy plus potential energy mgh1 equals to 1 over 2 kinetic energy half mv squared plus mgh2. So this is 2 2, this is 1 1. Okay, so substitute everything. 1 over 2 0.5 v1 squared plus 0.5 9.81 times with 14.2 equals to 1 over 2 0.5 times with 15 squared plus 0.5 9.81 times with 12. Okay, so we have a v1 equals to 13.48 meter per second. Okay, so that will be the speed of the bag at the point P. Where is it? Point P and then okay, the point P, this will be the speed. Okay, here. So for the C, okay, you may ask why is okay, why that you learn that is Vy equals 0 at the point P. Why we have a number here? It's because we are not talking about Vy, we are talking about Vx. Okay, so Vx has a value, Vy doesn't have the value. The V will be 13.48 meter per second. So goes with number C. So C, find the angle of projection. So we have to find how much is the angle of projection for the projection. Okay. So we know that this is over here is from the previous answer, that is 13.48 meter per second, and this is in V x only. Okay, solely on the Vx, Vy will be 0. So we can use the horizontal motion. Okay, from the horizontal motion we know that 15 cos theta equals to 13.48. Okay, and so again we have v1 equals to 15 cos theta. Okay, and theta will be equals to 26 degrees. Okay, so over here the angle will be 26 degrees. The last one, calculate the horizontal distance L of the sandbag when it hits the ground. So how much is the L over here? To find the L, we can use S equals to ut plus 1 over 2 gt squared. And this is we can use horizontal or vertical. We can use vertical. Okay, so for vertical, why we use vertical? Because we only have we have the information only on 12, we have 14, we have everything in the horizontal, right? The only thing we have information is this is 13.48 meter per second. You can find the if we have 13.8 means that from here to here, from this point to this point, the velocity will be equals. The velocity will be constant, but we need the time. How much is the time over here? So we cannot use horizontal motion to answer this question. You have to use the vertical motion, right? So if you're using vertical motion, okay, vertical motion, the one we can have is s equals to ut plus 1 over 2 at squared, okay, and we know that s over here is 12 meter height, okay. So we have to, before we do this kind of question, we have to know that vector is determined by positive and negative, okay. So you see that this part is we call as the base level, okay. And if we use a convection of, no, I mean the physics, I mean the physics idea, the sign of physics, that is positive to the right, positive to the to the top, okay, or going up positive, right and up is positive. So this 12 meter is pointing down from the base. So 12 meter is negative actually. Everything that goes up is positive here. Everything that goes down is the negative here. Okay. So you can see that this S, if we want to replace with 12 meter, it is a 12 negative 12 equals to u sine theta t minus 1 over 2 9.81 t squared. You can see that over here I put a negative. I put a negative because G is pointing downwards from the base level, is pointing downwards, downside, so negative. And this one negative because it's pointing downwards 12 by 12 meter. So S is negative 12. Okay, next. U sine theta. It is a positive or negative. If you check at the diagram, it is pointing upwards. So I didn't think that pointing upward positive, so that's why u sine theta is positive. Okay. And we're going to continue with the working. So equals to 6.576 t minus 4.905 t squared. So this is a quadratic equation, right? Okay. So going to end up, we're going to get the roots of the quadratic, that is at 4.905 t squared. Going to just rearrange the numbers. 6.576 t minus 12 equals to 0. So you have the roots, that is t equals to 2.372 second, or t equals to negative 1.031 second. So logically it's saying that if you go back to the time, it was t will be here is negative 1.031 second, and this part is 2.372 second. So we got the number. How much is the number? 2.372 second at the t over here. Then we can use the horizontal motion to find what is the length. Okay. So we use a t equals to 2.372 second, and we put into the horizontal motion. Horizontal motion, and L equals to 15 cos 26 degrees times with 2.372, that is equals to 31.98 meter. So the whole thing over here is 31.98 meter. Okay, for the next question, we have a question number question in the past year, that is 2017. STPM question number 16. A boy kicks a ball and reach a ball move with initial velocity 25 meter per second, and at angle 35 degrees to the horizontal, the ball reached the maximum height before landing to the his slide as shown in the diagram below. By neglecting the air resistance, determine the horizontal distance. So what will be the distance over here? Okay, so you see that it may reach actually they have 2 points over here. Okay, they have 8.6 meter before it flies to the highest point, and then when it drops you have 8.6. So actually we would came up with the quadratic equation where we have two roots. There are two sides of 8.6 meter left and 2.6 meter right. So never mind, let's try to find find what is the answer. Okay, 25 meter per second. So in the angle 35 degrees, so the horizontal will be the horizontal velocity will be 25 cos 35 degrees for the horizontal, and for vertical is 25 sine 35 degrees for the uh, vertical motion. So we have v, and I mean u in y. U in y will be 14.3 meter per second if you do the calculation, and u in x equals to 20.5 meter per second. Okay, so now we're going to use both of the equation, horizontally and vertically, to get the horizontal distance of x. Okay, so start with horizontal motion. We have x equals to 20 times 5t. Okay, so vertically, okay, and I can use that t equals to 20.5 divided by x. Okay. Or see, another way around, it should be okay, t equals to x divided by 20.5. That is not the real one. Okay, so vertically y is equals to 14.3 t minus 1 over 2 times with 9.81 times with a t squared. Okay, so y is 14.43 minus 1 over 2, 9.81 times t squared, and we want to find y when it is 8.6 meter. Okay, so in this case we have to substitute everything in this equation over here. I can see in this equation. So we have 8.6 equals to 14.3. T is the x over 20 divided by 5. So x, we substitute everything with x with the horizontal motion. So x divided by 20.5 and minus, this is 4.91, okay, times with x divided by 20.5, this is squared. Okay, so this is a quadratic equation. You can find the x by using the maths. You do the working and you find out that x has two roots. X is 42.26 meter, or x is 42.3 meter. Okay, so we are going to use 42.3 meter because 42.26 is on the left side, 42.3 meter is on the right side. Okay, so that will be the question number A. So the time flight of the ball, okay, so we use horizontal motion. Okay, so x equals to 20.5 t. Okay, so we're going to find the time of flight. That is we can use as x equals to 42.3. This is what we have before. It means that what is the length of it. So 42.3 equals to 20.5 t. So t equals to 2.06 second. Okay, this is time flight of the ball and it's only one mark on there. Okay, next, the speed of the ball during the impact. So we want to find how much is the v over here, vy, vx and vy. So find vx equals to 20.5 meter per second and vy, okay, vx does not change, vy equals to u plus at, and we have equals to v equals to 14.3 minus 9.81 times 2.06. Okay, this is vy. So it's equals to negative 5.91 and meter per second. So the speed, okay, v equals to square root of 20.5 squared plus 5.91 squared, okay, equals to 21.3 meter per second. Okay, okay, for this question, a tennis ball is being hit over the net is shown as a figure below. So 1 determine the initial velocity of the tennis ball of the vertical component. Number 2, calculate the time taken for the ball tennis to land. And 3, determine the angle of projection of the tennis ball above the horizontal. So we're going to start with number 1. Okay, so number 1, we only consider in the vertical motion, up down. So initial velocity u is sine theta. Okay, and u in vertical initial velocity v, u in vertical. Okay, I put that this one. Okay, so u sine theta, and v square equals to u square minus 2gs. Okay, so in the horizontal in the vertical motion, 0 equals to u sine theta squared minus 2g and s equals to 1. That is 1 meter. I mean that at the highest point. Okay, at the highest point, v y equals to 0, and this is 1 meter length to the top. Okay, so we're going to continue. Okay, so arrange the equation. U sine theta squared, okay, equals to 2 times 9.81. So u sine theta equals to 4.429 meter per second. So this is squared. You square root the gravity times value 2, then you have the answer. Okay, Number 2, calculate the time taken for tennis ball to land. So start with S equals to ut plus 1 over 2 at squared. Okay, we're going to use vertical motion also. Okay, so S equals to 0. Okay, and because at this point this is 0 in the y axis and 0 also in the y axis. Okay, so now we're going to continue. 4.429t minus 1 over 2 9.81t squared. Okay, quadratic equation again. 0 equals to t 4.429 minus 4.905 905t. Okay, and t you have equals to 0.903 second. So it takes 0.09 second to t over here 0.903 second. Okay, so goes to number 3, determine the angle projection of tennis ball above the horizontal. And this one we have we use the 4.29k. Use the horizontal motion, that is u sine theta equals to 4.429, put as a first equation. Now we consider the horizontal movement, that is x equals to ut. Okay, this is actually a vertical and this is horizontal. So 5.5 times 2, that is the whole range, 5 to 5 one side, 5.5 one side, equals to u cos theta times with 0.903. Okay, so you have u cos theta equals to 12.1816. This is second equation. So you divide 1 divided by 2. Okay, so you have tangent, right? Sine over cos, we have tangent. Tangent theta equals to 0.3636. So theta will be 19.98, and it is near to 20 degrees. So that will be the answer for number 3. Okay, so that's all the answer for all the equation exercises. Okay, see you again in the next time. Bye bye.